Okay. Okay, so now let's start talking about Three.js. Hold on. So tonight we'll be talking about Three.js. If you is everybody familiar with Three.js or no? Okay, so this will be a really good overview. So before we get into Three.js, we'll talk about who I am. So my name's Chris Schmitz. I'm one of the development team leads over at Paradowski Creative. It's an advertising agency in Brentwood. We do branding, websites, web applications for large clients. And recently we started using Three.js. We've actually used it for a while, but we had a couple of major projects recently, which is why I'm going to talk about it. One of the things to bring up is that I am not a designer. So I work with a lot of really talented designers and a lot of really talented design developers who are very strong on the aesthetic side, but I'm not. I'm a application developer who started working at an advertising agency. I'm really great with structure. I'm used to back-end code. I'm used to organizing things on the front end like JavaScript clients, but I'm not good with the art side of it. So the stuff that we're going to see tonight, the stuff that I've built is very simple, but hopefully that will help convey what it's like to work, the basics of working with Three.js. So, but don't and we'll see some cool stuff. I didn't make that dancing demo. I wish I had because it's really cool. But yeah, so we'll see some cool stuff. But the sample code that I'm going to show is a very intro level code base. Let's see, and so we're going to talk about Three.js. Three.js is a lightweight. Three.js is a lightweight JavaScript framework that allows you to easily work with WebGL in your browser to render 3D graphics. You can also render 2D graphics, and I guess I'll talk about that too. But the primary focus is rendering three-dimensional graphics onto a browser. And something else that's important to talk about is what WebGL is. So if you're not familiar with WebGL, it's a JavaScript API that allows you to access your computer's graphics hardware. So being able to use the GPU to render out these three-dimensional scenes, which is like an intensive process. Like if I don't know if you can hear it, and you'll probably hear it more, but my computer's fans are going to ramp up over the course of this project, partially because I'm recording and showing 3D demos, but it is Three.js is taking advantage of your computer's hardware to render out 3D graphics. Let's see. So before we get into a bunch of code, I wanted to talk a little bit about why you would want to build 3D in the browser versus a native application. And this is a conversation that we at Paradowski had a while ago, and really any project that we're going to use 3D on, we have this conversation of like, should we do it on the web? Should we do it in a native application? And why? So whenever we talk about browser versus native application, and since we are a web-focused group, I want to talk about why you would want to do it in the browser. At Paradowski, the big things for us was that it allowed us to leverage our existing skill set. So all the developers that work know JavaScript, work with JavaScript daily. Even the people who are more back-end focused know how to write in Node. So JavaScript is a familiar tool set for us. So being able to build these experiences using our skills our existing skills without having to learn a whole lot of new stuff is an advantage. It also means that we have a single code base. If you've ever developed native applications for native mobile applications like on iOS or Android, you will normally have like two separate code bases, one for iOS, one for Android. Doing 3D in the browser and really doing anything in the browser means that you have a single code base that you're going to be working from, which is an advantage in a lot of ways. Let's see. So it's easier to deliver, and it's a lower barrier of entry. And with that, I speak mainly of the browser itself. So if you build a native application, that means that you have to submit it to app stores. It has to pass approval. For Android, it's not that difficult, but for iOS, they have pretty stringent approval processes. Then it's in that store. Your user then has to download it to their phone and launch it. And then anytime there's an update, they have to approve that update. So there's like the delivery is a little bit like there's more that you have to do to get your application onto your phone, onto the user's phone, as opposed to a web experience, either a website or a web app. You just have the user go to a particular URL. And the application is installed because the browser has already been installed. You're just loading your application into it. It also means that you are in control of when things update. So like any web experience, if you have an update that you need to push and needs to be live immediately, you're updating one source of truth that all of your users are connecting to, as opposed to pushing up to the app store and then pushing down to their phones and hoping that they do the update. The experience is more accessible to the end user in the sense that you're using a tool, the browser, that they are already familiar with, and 3JS specifically can be integrated into a larger web experience. It's not like all the stuff that we're going to see. 3JS is taking up the entire browser window and is the primary focus, but the rendering point for 3JS is just a canvas element. So you can put a 3JS experience into a smaller section of an overall website, either on a page or in a part of a page or on a page on its own. It can be incorporated really easily into an existing web experience. And that said, pick the right tool for the right job. There are lots of things that 3JS is good for, and a lot of things that a lot of the JavaScript 3D packages, the different libraries that do the same thing. There are a lot of things that they're good for, but they're not the right tool for every single job. We'll talk about some of the issues, but I don't want to stand here and say do it the web way, because sometimes the web way isn't the right way. But there are a lot of cases where it is. So 3JS can be used for two-dimensional rendering, but we're not going to go over any of that. And actually, I was going to put just like a video of a 2D 3JS experience, but I couldn't find a good example that I wanted to show, so I just left it out. There are a lot of two-dimensional libraries that focus on two-dimensional experiences, some of which I'll mention towards the end, but 3JS's main focus is on 3D, though it can do 2D. So now I want to talk about the different parts of the 3JS experience. Whenever you look at 3JS examples, and there are tons on the 3JS site, and as you look through 3D stuff on the web, a lot of times it will be 3JS under the hood, and the source code for it can be really intimidating. But there are a couple of key parts of every 3JS experience, or most 3JS experience, that I wanted to cover. They're key to know. And after we go through this, we'll start looking at some of the demo code. So the main parts of a 3JS experience starts with the scene. So the scene is just it's kind of a container that you're putting all of your three-dimensional objects in, your camera in, all of the pieces that are going to make up the experience go into a scene. You can have multiple scenes, like you can hide one scene and show a different scene, but it's the main way that you group objects together. Once you're within a scene, you can have other subgroups that, like using the 3JS group class, and those are ways of like attaching different parts within the scene to each other. But the main group that you're always going to have is the scene, and that's what the renderer is going to use to paint your screen. The next main part is the camera. The camera is your perspective into the scene, like where the user is going to be looking at the 3D stuff that you've placed around, how they're going, whenever they move through the scene, it will be from the camera's perspective. Let's see. And with the camera, there's a, wrong screen. So there's an important concept to understand when it comes to the camera, and that is the frustum. I never know if I'm pronouncing that right, but the idea is this is the outline of what you're seeing from the camera's perspective. So where each of those axes meet is where the camera is, and it's pointing forward into that kind of conical shape or the pyramid shape. The field of view controls the range of the objects that you're going to see, and then this near plane says anything in front of this near plane is not going to render. You're not going to see it. And then anything past this far plane is not going to render. You won't see it. So based on the size and shape of this center part is going to be what is in view of the camera. Both from the perspective of what you want to show and hide, but then also when the renderer repaints the scene, like it goes through and draws the scene on the screen, anything that's outside of that center part doesn't get rendered. So it's also a performance thing. So 3D objects. These are the actual 3D pieces that you're going to be putting onto the screen so that the user can see them. The 3D objects. Sorry, I'll make sure I'm going through my notes as well. Before I switch over to there, the 3D objects are made up of a couple of different pieces. The very basic ones are made up of geometry, so the skeleton of the 3D object that you're going to be creating, and then the material. So for that skeleton, the skin that's going to go over there that's going to give it whatever the look is, and then those two together create a mesh. So breaking it down even further, all of the things that are being rendered out in Three.js are vector graphics. So that means we have a whole bunch of vertices that show where the 3D shape comes to points where things kind of shape their way out between straight lines. The edges, which are the lines that connect the vertices to create the shape. The faces, which are whenever you connect all the vertices with the edges, that plane becomes is considered a face, and the face faces one direction. So whenever we look at this face here, we are seeing the front of this face. The faces back here we don't see because they don't exist from the other side. You're dealing with a truly two-dimensional object. Yeah.
It's like a one-way mirror.
Yes. Yeah. That's a good way of thinking of it. Once those faces are all assembled and put next to each other, then we get the polygon. So whenever you think about old, like a Nintendo 64, and how not pixelated, but how poly those shapes were, those are all of those faces being put together. So when you think about Mario being all made of triangles and stuff like that, yeah. It's all the polygons. Those polygons come together and create surfaces, and then once those surfaces are together, you have your three-dimensional object. The only thing that at a very basic level, Three.js gets you to this point. You don't have to. You can assemble three-dimensional objects out of each of those constituent parts, but you can use Three.js helpers to define a shape, and then start from here going forward, which is a major help. Yes. It's not the yeah, it's a different thing, and this is one of the areas that gets a little bit fuzzy for me because I'm still new, but the it's because I'm pretty sure it is a performance thing. You're only wanting to render one side, like you're only wanting to render what the user can see, or what the user is supposed to see, and then the other side, there's no point in drawing it if it's not facing the camera because no one's going to see it, unless you have a three-dimensional object that you're going to turn, and then maybe you will have faces, that are still on the outside, like. Could you hand me my dragon, please?
My pleasure.
Like if we're looking at the wing of this dragon, we want to see the outside of this wing, and if we turn it around, we want to see the inside of this wing, but it's not a flat object. It's actually some polygons on this side that show the face, and then polygons on this side that show a face going that way. So you have a little bit of a cavity, but inside there, it's hollow. It's like it's completely two-dimensional. It's hollow, and the inside of that doesn't render. So I don't know that it is specifically for performance purposes, but you get a performance advantage by not rendering the back of stuff.
If I can add to it, one thing you left out was lights. And,
Oh, yes.
And one of the things I assume is that there's always a light at the camera.
Mm-hmm.
So how this is actually rendered as far as the light goes is you only see what the light reflects. So one side will be reflective, so that's what you get to see. The other side, it's like pure black hole, and it will absorb the light. So light will only pass through reflect off of it one direction. So it's a performance issue for it's called ray tracing, because a ray of light, and then where it bounces back to the camera, think of like a radar detector. That's how the camera knows what to draw.
Yes. So let's see. So yeah. So whenever we're creating 3D objects within Three.js, the goal is to get to a mesh, and the mesh is what you're going to add to your scene and what you will interact with. With the mesh, those constituent parts you could still interact with, like the geometry and the material. You could still interact with it after it's in mesh form and after it's in the scene. But the mesh is the combination of all of those so that the renderer can draw it. And that brings us to the renderer. So this is the tool that actually draws the objects onto the screen. And it converts, so we've been talking about all these 3D objects, their position in space, like the vertices that are the XYZ coordinates of where the points are, and the edges are drawn in between them. But we don't see that on the screen. We see a two-dimensional representation of that. So the renderer is what says, okay, you've placed all these things in a three-dimensional space, so let me translate this into a two-dimensional space and then draw it or shade. Well, I don't know that this is shading. I guess it's kind of shading. Let me draw it across the canvas and onto your screen. You can think of it like taking a picture. Like if I stood up here and took a picture now, the picture that I have is of a three-dimensional space, but it is a two-dimensional representation of that. So the renderer essentially does that. Let's see. There are different kinds of the main renderer that we're going to be talking about is the WebGL renderer, the one that uses your browser's tools to draw onto a canvas. Three.js has a couple of different renderers. They're mostly used as fallback tools for older browsers. But yeah, there are other renders. Some of the renders are 2D renderers. The main one we're going to be working with is the WebGL renderer. And the last major part of a Three.js experience is the animation loop. So we're going to create our scene. We're going to put a whole bunch of objects into our scene, and then we're going to tell the renderer draw that scene onto our screen. But that happens once. So the animation loop is where we say, okay, and do it again, and do it again. While we tell it to do it again, we can, in between each pass, we can adjust the 3D objects within the scene to make them change before we draw it out again. And that's what the animation is. And you can think of that as like cells in a film strip. You have one state that is slowly changing as the film strip goes up. The animation loop is the projector going through each of those different scenes. Let's see. The animation, and we'll see it in just a second, the animation uses, for Three.js, uses the request animation loop that's built into browsers. You could do animation with a JavaScript set interval and just like manually or use that as a loop to adjust the 3D objects and then call the renderer. The request animation loop gives you a little bit of an advantage because it will stop running if you switch to a different tab. So and there are a couple of different advantages that you get, but request animation loop is used for animation and tries to save you a little bit on performance. Better than just a regular interval. Okay, so let's look at our first demo. So all the demos I'm going to show tonight are up on my GitHub under the Three.js Overview talk. It's the basic example, the helpers example, and the dragging example. So if you want to pull this down, I'll make sure that the link to this is in the follow-up notes, but you can pull all these down. I'm not using any build tools for this. Launch it in Chrome. It probably won't run in Internet Explorer. It'll probably run in Firefox. But my goal with these demos was to make it as plain as possible, so that you could just pull it down and worry about looking at 3 and not dealing with Webpack or Gulp or anything like that. So let's look at the basic example. So this is what we're going to look at, is a blank scene with a 3-dimensional cube that is rotating around. And then I guess I should also say, in these examples, I have most of the code that you're going to be looking at are in the JavaScript files, and I have an annotated version and then a version without annotation, because what we're writing is not really a whole lot. It's 58 lines of JavaScript, which is not much at all. But I didn't want the heavy annotation to make it look like this is a massive process. So definitely go back and look through all these. So I broke this out into each of those major sections. I think there may be 1 or 2 major sections I didn't cover in the slides, but we'll step through each of those. And they're also not in the same order. These steps, as long as you have everything defined before you call your animation loop, it doesn't matter which order you create any of these objects, because you knit them all together. You knit them together as you're going, and then the animation loop is where most things get tied together. So first we'll talk about the renderer. So the renderer, whenever you create a new Three.js WebGL renderer, it will give you an object, and that object is going to create a canvas element that gets placed into your browser window, and then it controls what gets drawn to that canvas element. Let's see. So whenever we create the renderer, you want to set the size of it. This is going to be the literal outer dimensions that the renderer is going to, or the size of the canvas that the renderer is going to draw to. We want this to take up the entire window, so we're just going to grab the window inner width and height and say just draw over the entire thing. And then we are going to append that to the body, the index.html file.
Can you make the canvas size higher
Probably. I mean, like, yeah, you'll get the scroll bars because it's just going to control the size of the canvas element. So if the element extends past the edges of the browser, you're going to get the scroll bars like you would with any other element that you
But
oversize.
it's literally in pixels.
Yes. 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 Yes.
Because SVG doesn't work that way.
It's interesting. Once you're So there is an SVG renderer, like a specifically SVG renderer, and if SVGs don't work in pixels under the hood, it probably does some kind of a translation to draw it out to the screen. I'm gonna switch back to the index.html file really quick. So the index file that we're dealing with is just a really bare bones HTML file. There's a little bit of style to adjust like the canvas to make sure that it doesn't, or that the body doesn't have margin, and that the canvas can take up as much space as it needs, in addition to the settings that we're giving it. And then we're just pulling in Three.js, a library called Orbit Controls that we're going to use to navigate around, and then our JavaScript file. So that's it. It doesn't need to be any massive markup. You're really just giving the Three.js a spot to land. So we create our renderer, and then we'll go through and create our scene. The scene, we could just create a new instance of Three.js scene. You don't have to put this window.scene into your code, and really, if you're going to do production code, like if you're about to push this to production, you probably don't want that line, because if you attach it to the window, people can get into the experience and interact with it. They're probably not going to be able to do anything malicious with it, but they have access to the live running scene, so you could usually take that out. But we're putting it in here so that we can get to it from the console, but also so that the Three.js browser dev tools can see the scene and walk over it. So we'll create the scene, and with the scene and with other objects that we're going to place into the scene, we'll give it a human readable name. Whenever you create these instances of these Three.js objects, they get a UUID assigned to them, so you can access them by ID, but it's way easier to look at the browser dev tools if you have a name assigned to it. So let's see. Oop. Let me blow that up a little bit. So and this is jumping ahead just a little bit, but these are the browser dev tools for Three.js, and this is the name that we're assigning to it. If you don't put a name, it says like undefined, and the more stuff you have in it, you have this big tree that just says undefined all over the place. So it's a good idea to give your objects names. So we'll create the scene, and then we'll add a camera to it. There are a bunch of different types of cameras, and they're used for different things. The main camera that we'll be using, and that you'll probably end up using, is a perspective camera. It gives you a realistic view into your scene. And whenever we create a new perspective camera, we define the frustum here. So we say that our field of view is 75, which controls that angle that we're able to see. We set the aspect ratio that is going to be drawn. So this needs to match whatever the size of your canvas is, so it doesn't like if you like in film, like whenever film was actually on film, there were two main types of film. There was widescreen and flat. And flat was kind of like a box, and then widescreen was a rectangle. And if you projected one of those aspect ratios on the other, you would smash a widescreen, or you'd stretch out a flat, and it would look weird. And this is the same concept. And then the last two values are that near and far that we talked about before. How close can objects get before you can't see them anymore? How far away can they get before you can't see them anymore? So we'll define that, and then we will, let's see, and then for Yeah, so far we've not added that to the scene. We've not attached the scene to the renderer. So we're still just defining the very first parts of our experience. So now we'll add our our 3D objects. So those and the basic steps or the steps for that, if you're using 3JS's helper methods to create a 3D object, is to create the geometry, the shape, that skeleton that we're going to use to draw it. Create the material, which is the skin. It's what's going to be shaded onto those faces. And then we are going to create a mesh, the mesh that combines the geometry with the material, and then we're going to add that mesh to the scene. So, and this can get more elaborate as you're making shapes that aren't just really basic geometric shapes, but ultimately it's going to be this: like create a skeleton, create a skin, slap the skin on the skeleton, slap the entire thing into the scene. And I would like in each of the notes sections, I try where it made sense to look at the documentation or look at examples. I try to put links in there, so hopefully this will be a helpful guide after the fact. So here,
Can I clarify
yep,
on the
yep,
material
yep.
part? Or maybe you'll cover this later, so tell me if you do.
Mhm.
The material part is you're literally taking an image and wrapping it onto the mesh
Yep.
that you previously defined, right?
Yeah.
So like if you were creating a red car, you would paint it, you would do a red image potentially with stripes and then lay it on that mesh.
Yep. Yeah. Yeah. It would be an image or like a particular color, or you can use a shader that is creating programmatically creating a material. I don't know how the best way of saying it, but basically, if the renderer is drawing this three-dimensional scene onto your browser window, a shader is drawing something onto a three-dimensional object. So, but yeah, you were taking some kind of a visual and wrapping it around. And we can look at some of these two examples, or the three examples I have don't use images as materials, but we could take a look at one because it's not really all that difficult, at least for the simple stuff. So we'll create a box geometry and we're defining its dimensions and its constructor. And then we're using a mesh normal material. There are a bunch of different materials that you could use within three. The mesh normal material has specific properties, like it's affected by light, and it'll cast a shadow, it'll reflect stuff. But yeah, so we're using that, and then we just say, all right, take that geometry and that material, put it together, create a mesh, and we're calling it cube. We're giving cube a name so that we can refer to it in the dev tools, and then we're adding it to the scene. And then each three-dimensional object, this one only has one, but each time that you add a three-dimensional object, you're doing these steps and then saying scene.add, scene.add. Once we, yep.
Sorry, how do you, when you add an object to your scene, how do you determine where it lands in the scene?
So everything, that is a good question. When you add something to the scene, it is positioned relative to the scene's origin point. So that XYZ axis that we were looking at, so the XYZ axis that we were looking at from the camera, the scene has an XYZ axis of its own, and you are whenever you place this something into it, you're placing it at X0, Y0, Z0. And once it's in there, you could say, okay, relative to this origin point, move it this far away, and that's how you can move things in the scene. And as you move things around, like as we get a little bit further down, you can change your object's XYZ or its Cartesian coordinates to move it around and like change its shape or yeah, position it differently. So I keep doing this. Fusion or 3JS's axis, it goes X Y Z. So it positions 000 in this bottom corner. So yeah.
Yes.
Yeah, and then like Fusion 360, which is a 3D modeling tool that I use, its axis is like tilted to the side, which goofs me up a whole bunch. But yeah, whenever we think about the positioning, and actually we're positioning the camera here. Um, we could position each. Let's see.
So is the object, is its center then preference, or does it have the same XYZ? Is it in its bottom corner of its like a square that's drawn around it?
It is in the. Man, that is a good question. I'm not sure. We have access helpers that we'll see in a little bit, so we can try it out and see. But yeah, so whenever we're saying the position for a 3D object, and cameras at their very base are object 3D objects that can have a XYZ position, we're setting values like either positively on the x-axis or negatively on the x-axis, positively on the y-axis or negatively on the y-axis, and then positively on the z-axis or negatively on the z-axis. So that's how you're determining where this is going to be in three-dimensional space. You can also do rotations along those same three axes. And it's set the same way. Instead of position, you would say camera dot rotation dot x, and then tell it how many radians to rotate along that axis. So I'm going to delete that for now. So we've created a 3D object. We've added it to the scene, and then we're moving the camera so that we can so the camera that is positioned at the center of the scene as well. So we're moving it back so that the cube is at the center of the scene, and the camera is going to be able to look back at it. Let's see. So, and at this point, I left this in here and left this commented out. At this point, we have everything that we need to actually render out a scene. So if we didn't want to add anything to it, if we just wanted a cube to render out to our browser window, we could use this animation loop. Let's see. Let me uncomment it so that we can see it. And this is what a really basic animation loop looks like. It's a function that you call that at the very top of it says request animation frame. Well, and actually this doesn't need to be up at the top. The very basic animation function before we talk about the loop itself is this. You call a function, you do whatever changes to the objects that are in the scene for that one frame, and then you tell the renderer, okay, here's your scene, here's the camera that's the user's perspective into the scene, draw everything out in 2 dimensions and onto that canvas. And if you do it here, and that so we define this function and then we immediately call it. So so 3JS is going to draw that to the browser, and it's going to stop. And if you leave it there, you're going to get a static image of the things drawn out to the screen. The way that we get animation, so that we see the things moving like you would expect in like a 3JS experience, is to make this a loop. This isn't recursion. We're not calling animation from animation, so it's not like we're building up a big recursion tail when it comes to what we're calling. We're just calling the function. We're saying, hey, request animation frame. The next time you go to paint the browser window, fire this animation function as well. So the request animation frame. The browser is constantly repainting itself, or at least it's going through and determining if it needs to repaint itself. So each time it does that check, it's also going to fire our hook. So that's how we're able to draw this. Each little increment of rotation that we're seeing here is a frame being drawn out to the screen. And actually, if we, let's see. So if we do an early return here and save it, oh, wait a minute, early return is probably not going to work. Let's just delete everything under so that we can see it. So we've got our box drawing, and if we say so if we just increment a variable every time that the request animation is being called, we can see that it's firing. Like so, each of these little turns is the renderer drawing over and over again. And this is why whenever you have a large, very detailed scene, your fans are probably going to flare up because it's doing a whole lot of processing. It's using your GPU, so it's doing it as optimally as it can, but it's doing a big task. And actually, to drive home the frame idea, if we comment out request animation frame, this is what we get. We called request animation frame once. We draw out the scene in the like with the cube in its current position, and then we stop. We turn that back on. We get our animation. So that's it. Like for like the very, very basics of what it takes to create a Three.js experience, it's just that. It's building that up, setting it up, and letting it run. But we want to do more than that. If I leave it this way, there's no interaction with this at all. I'm clicking and dragging, and I'm not actually able to interact with the experience. So if I hop all the way back. Let me hide that so we have more room. Ugh, what am I doing? Yep. Okay, so if all that's coming to back out, before we call the renderer, we can define a couple of different things. So for most well, I guess I shouldn't say for most Three.js experiences. For all the stuff that we've wanted to build at work, we want it to be interactive. We want the user to be able to navigate around in this experience and interact with the objects inside of it. We're going to talk about the navigating around. We're not going to talk about the interacting with it with objects. That takes ray tracing that Matt mentioned earlier. And I didn't get to the point where I added to this demo. And to be honest, for an intro, it's a little bit beyond the scope of like the intro to Three.js talk. But yeah, the idea of ray tracing is from the camera's perspective. I want to know if like where I'm pointing is intersecting with anything in the scene. So I'm like during one of these loops, or like we're gonna move everything around the scene, and then right before we do the animation loop, we're going to say, okay, from here I'm going to just look straight. Now, how many things I intersect with, and if I intersected with something, is it the thing that I want to interact with? And then based on that, you could do different actions. So it's very cool. There are other examples of it. We're not going to cover it here tonight. We are going to cover controls. So Three.js has a library called Orbit Controls that allows you to they can attach to a camera and allow you to rotate and like move the camera essentially. So to do that, we'll create we'll instantiate an Orbit Controls instance and pass in the camera that we want to attach it to, and that will become our controls. From here, we can do other things, just regular JavaScript stuff of the Orbit Controls creates its own DOM element on the inside that we can hang event listeners onto. So we could do our regular JavaScript mouse up, mouse down. We could do other hooks, or event hooks that we want to attach to them, and then define our own functions of whenever that happens, what am I going to do. In this particular case, whenever we click the mouse down, we want to be able to move the Orbit Controls down, and then whenever we and then also pause the cube so that it's not rotating while we're trying to move it, because we want to orbit the camera around so we can look at the cube, and then whenever the mouse is up, we want to undo that. So we attach the on mouse down, or the mouse down and mouse up event listeners, we create functions for those so that we can hook into that and update our variable, which is by default set to false. And so it's on the camera, and then our render, like the camera is what the, we're going to tell the renderer, here's my scene, here's my camera that now has orbit controls on it. So draw out the scene. The difference in this animation function, this animation loop, is that now every time it's going to draw something, we're going to say, hey, is the mouse down? If it's not down, we know that we want to rotate the cube, so increment its rotation. So like move it just a little bit on those two axes. If the mouse is down, like so if we've clicked, don't rotate it because we're going to rotate the camera. Whenever you have orbit controls on, you have to tell the controls to update. So basically the scene has adjusted and the camera may have adjusted. So the orbit controls has to know you need to update yourself relative to the scene and to the camera. So we update the controls and then we say renderer, everything's ready in the scene, everything's ready with the camera, so draw it onto the scene. And that's why we can, grab the cube and start moving it around. When we're doing this, we're not moving the cube, we're moving the camera relative to wherever the cube is at the moment. Because the camera is our perspective, it makes it look like we're controlling the cube itself, but we're just moving the camera around. You can, obviously you can move the box, and you can move the box and the camera in tandem. Like if we took off this conditional, we can move it and like let the cube rotate at the same time. But for our interaction, we want to be able to pause the cube.
So you pause the cube, and then when you move it around while you have your mouse compressed,
Mm-hmm.
and when you release the mouse, does it start spinning from that new point, or does it go
It's
back to the original point?
Yes, it starts spinning from, the cube starts spinning from, hold on, no. The cube doesn't start spinning from a new point because it doesn't have a new point. The camera moved.
Right.
So it's just continuing whatever rotation that it had. If you did move the cube, like if the hook that you have actually changes the positioning of the cube itself, it will start from wherever you let go. Like if you had a bunch of boxes in a scene and they weren't moving and you were just wanting to position the boxes within the scene, you could grab the box, like on mouse down, like say on mouse down, what object do I have selected from ray tracing? And then with that object, adjust the Cartesian coordinates to move it around, or adjust its rotational radians to move it and stuff like that. And then whenever you let go of it, it will just have those coordinates. So yeah, so it'll start off from where you left it.
At this point, we're not moving objects relative to one another, we're only moving them relative to the camera. Right, we're moving the camera around the object.
Yes.
If you wanted to move objects relative to one another, you literally have to move the object.
Yes. Yep. Yeah, and they would move relative to the scene. You could do like, so I'm not showing it in any of this, but like every all these objects are based in a, let's see. Let's hop into the Three.js documentation. The Three.js documentation is both terrific and horrible. It is very thorough. It's a little bit, sometimes it could be tedious to navigate through because it's using object extension, and sometimes you don't know what it's extending from. But at the very basis of all these 3D objects that you're putting into the scene is this object 3D, and it has let's see, it has. Oh shoot, what was I about to show? It has all the bits and pieces that you would need to define the object and to tell its position. There we go. So like it has all the details that make up what like this like what that object is and where it exists in space. And with all of the object 3Ds, you could tell you could see its position at any given point in time. So you could do things like if I had two boxes that were right next to each other and I wanted to move this box relative to this box, instead of moving this box, instead of saying box like position like 3 that would move it not relative to this box but relative to the scene's origin. You could say move it relative to this like this box's x-axis plus 3 to like move it relative to the other one. And you could do that with rotations. There are also really nice helper functions like with the camera. I can move it all the way out. Like when in the demo that I had, I can move it all the way out, and I just know because the box here is at the origin point that if I move it just across the z-axis, it will still be looking at the box. If I move the camera somewhere else, it may be like if the box is here and I move the camera here, it's still facing that direction. So I need to do some math to figure out, okay, based on its direction, how do I tell it to look at that box? And maybe if the box is at the origin, it's not that big of a deal. But if your camera's here and your box is over here, it's like, oh crap, how am I going to figure that out? Three.js has a function that says look at, and you can give it the box object or the mesh itself, and it will just go and do the math for you. So it's super nice. And if it was all math based, I probably wouldn't be giving this presentation. But like you could do it at a math level. You could get down to doing things like using quaternions to rotate objects and stuff like that, and drawing vectors and like doing vector math if you want to. But there are a lot of helper functions that let you get past that stuff, or at least shortcut it so you can focus on building the experience and not necessarily doing what I consider tedious math. So that's it for the really basic demo. Even after adding in orbit controls, that's it, and you have a Three.js experience where you can do some basic interactions. Something to point out is that I didn't add a light to this scene. So it will, with this particular material, with the mesh normal material, it will render even if you don't have a light. You can interact with it with a light, but it doesn't require a light. There are other materials like the mesh basic material that doesn't interact with the light whatsoever. It just shades it a color, and that's it. Which makes it a little bit difficult whenever you're talking about like a box. It just looks weird. But let's go back to the slides. Okay, so so those are the basics of creating an experience. But once you're actually building a project with it, you need more insight into what's going on. Part of that is your JavaScript console. Whenever you attach the scene to the window, let's see. So in this example, because it's attached to the window, I can just type in scene and get access to that scene object. And then I can look at the children of the scene and see the children. I can navigate through it that way and interact with it that way. And really, whenever we are building these Three.js experiences, that actually ended up being the main way that we interacted with stuff. Either diving through the scene or doing things like scene gets scene gets child by name, and then did I name a box? What did I name it? Render scene. Cute name, box mesh. Oh, jeez. Who built this demo code? Sloppy shit. So, and you can use selectors to grab things within the scene, similar to how you would just in regular JavaScript. So, so you can do a lot of detailed work in the console, especially which is really helpful in something that is a little bit harder to tell what the state is at any given time, like a three-dimensional experience. If you're talking about regular web development, even if you're dealing with like a JavaScript client where the state has shifted a whole bunch, at any given time, the state kind of stops moving until you interact with it again, or unless you have something running in the background, the state stops and you can inspect it at that given point. The state on this changes all the time. The box mesh, the position. Oh wait a minute, nope. Yeah. The rotation is constantly changing each time the frame is being rendered. So looking at it just in code, or trying to like to kind of like divine the state based on what you're looking at becomes a little bit more difficult because the state is constantly shifting. Being able to get to it from the console is a critical thing whenever you're actually building experience. Having access to developer tools that allow you to look through the experience, so that you're not doing these the query selectors. Let's see, is very helpful. The dev tools for Three.js are good. They're not fantastic, especially if you're used to things like developing JavaScript with JavaScript tools like React or Vue, or like I guess Angular probably has browser tools as well. Like those browser dev tools are like very well polished and like they're very user friendly. The dev tools here are functional. They're not fantastic, but they will give you some insight past just the console, and they will make grabbing certain things a little bit easier. And they're interactive, so you can go through and do some of your adjustments here in the dev tools, which is super helpful, especially if you're positioning a whole bunch of stuff within a scene. Just getting it there and then using the dev tools to move it into place can be really helpful, even over the console, because the console would be like, all right, select the element and then set the like the x value to this. Oh, wait a minute, it's not exactly where I want it. Set the x value to this. Oh, wait a minute, it's not. And like doing that over and over again, as opposed to being able to come in here and say, that's about where I want it. The position is blank. Move that to your code. Move on. So dev tools are very important. The other thing that is important are helpers. So even with the dev tools, and even with access to the console, it's kind of hard to picture some of the things that we're seeing. Like in this scene, especially now that I've moved these orbit controls around, how do I tell where the scene origin is? Like it's like I don't know. It's a black void. It's like in this case, it's a literal black void. There's nothing there, so it's hard to tell where that is. With this cube rotating, how do I tell where its origin point is? Like with multiple objects on the scene, how can I visualize where they are so that whenever I go back to my code where I'm defining the starting point of the state of this scene, like how I know how to adjust it to whatever I'm trying to do. And that's where Three's helper tools come in, and that's where we look at another demo. So if we back out and take a look at the helper example, we see the same cube that we were working on before, but the scene's a little bit different. We're drawing the cube. We're rotating it, but now we have some helpers that kind of give us context of what we're looking at. On the left, in this example, I'm using the renderer to draw onto the browser window multiple times per frame. So here we have what our normal view is, but we have a ground plane that starts from the scene's origin point. So we can see, so that's the answer to where does the origin point start on a 3D object. It starts in the center of the object, because that cube is still placed at just like 0, 0, 0.
So that's how the cube method draws.
Yes.
If you drew it by hand, it wouldn't necessarily start there because you would dictate where it started.
Yeah, that's fair. I haven't drawn any shapes by hand. That's what some of the other developers have done. but I'm more of a structure person. So we have the view that we were seeing before, and then over on the side, there are actually two, and we'll look at the code for this in just a second. There are actually two cameras here. We have our main camera that we had before, and then we have a second camera that is floating up here to let us see the first camera and the rest of the scene from a different angle. And from here, we could see that frustum that we were talking about before. So if we rotate it, here we could see, so this is where the camera's origin point is. It's pointing this direction. This little blue triangle says the camera, this is up relative to the camera. And then here's our field of view. So we're seeing at this angle here. And then here's our near boundary and our far boundary. So as we move the camera, like whenever we move it just slightly out, so that the cube is kind of riding on that outer boundary, we can see that we can't see the entire thing. So the stuff on the other side of this boundary is not getting rendered, which is, I mean, if that's what you're going for, is helpful. It's also a performance thing. We're only worried about what's drawing in here. And similarly, if we move it too close, that's how we're looking inside. And actually, that's the other side of those faces. We're looking through the cube right now. So whenever we're seeing it, we're not seeing the inside face of the cube. There's just nothing to see. So we're just seeing right through it, the two-way mirror explanation. So we've got a plane helper that's showing us our ground plane, starting at the origin of the scene. We have our camera helper, which is showing us the frustum of the camera, and allows us to interact with it so that we can see the cube. And then we have an axis helper, which is right now attached to the origin point. It's hard to see because the cube is on top of it, but it shows us our our X, Y, Z axes. In this demo, I wanted to make it interactive on both sides. So whenever you click on this, you can see control camera 1. Whenever you click on this, you control camera 2. So without moving that, you can kind of get an idea of like, okay, this is what the frustum looks like, and then you could switch back, move it around, and kind of see where it is. Down? Yeah. So let's look at the demo code that defines that scene. So this is the helper example. The HTML file is pretty much the same. The only difference here is that I have HTML elements on the screen that we're interacting with to switch back and forth between the camera. So there's some style here. And then let's see, we've got the actual button elements. And this is another example of how, or this is an example of how the Three.js experience doesn't need to be only the Three.js experience. You can intermingle it with HTML elements. We're pulling in our 3 library, we're pulling in orbit controls again, and we're pulling in our helpers, or our helper.js, which is where we're defining our scene. All right, so in this particular case, I'm pulling in the camera controls from a module. I can't remember if I did that in the other one, but this is just like this is an ES6 module import. This is one of the reasons why you have to use Chrome for it, because Chrome supports it. It supports imports like this. Firefox, I believe, does. I would be surprised if Internet Explorer did. Maybe Edge. One of the things to note is that if you're going to import like this, and this isn't a Three.js thing, it's just a JavaScript thing, you have to make sure that the file that is going to do that imports, its script tag has a module type, and that will allow you to do the module importing for JavaScript stuff, which is really helpful when you're doing demos like this, because I can abstract stuff without it getting super complicated. Oh, and actually, this is a class that I abstracted so that I wasn't overloading this file, and it's just the class that I'm using to to switch the cameras back and forth. So there's a bunch of JavaScript here that says here's camera 1, here's camera 2, here are the buttons. This is what you do when you click the buttons back and forth. The only important part as far as Three.js goes is that this is how we're switching the cameras. If we're clicking that button and this attach controls the camera handler or method fires, it's going to say, okay, what camera am I attaching to? If it's camera 1, then I'm going to handle the button state, and then I'm going to say the orbit controls, the object that it's going to be attaching to is camera 1, like the actual camera object. If we clicked on the camera 2 button, we handle the button state, and we just say camera 2, this controls, this is now your object. So we're not creating two different sets of orbit controls. We're just creating one set and then switching out which camera it's attached to. So we import that. We do the same stuff that we were doing before as far as grabbing the dimensions of the window. I'm grabbing things separately here so that we can do some math with the screen width and the aspect ratio, so that we can draw half of the window and then draw the other half dependably. It's not crazy math. It's just dividing by 2. So we grab all the information that we need to know the size of the window that we're going to draw to, and then we create our renderer. In this particular case, this has nothing to do with the helpers. This is just me doing like a fancy backflip. Whenever that the animation frame runs, if the renderer is by default set to automatically clear everything that's in the scene, so that it can redraw everything in it. So basically, whenever you say renderer render and you pass it the scene and the camera, the first thing that it does is say, okay, delete everything on the window, like on the browser window that was there before. Everything in the canvas, just get rid of it. And now I'm going to start drawing everything fresh. In this particular case, we want to draw half of the window, and then we want to draw the other half. So we're going to have to tell the renderer to fire twice, and we don't want to delete that first half. So we're going to say, don't auto clear, we'll just auto clear, or we'll clear the scene manually in our animation loop. So that's all that's doing. We set the size of the renderer again, and then we attach it to the DOM. From here, we go through again and create our scene. We give our scene a name. We create the geometry. We give it the dimensions. We tell it what material to draw, to use to shade it, and then we create the mesh. We give the box a name, add it to the scene. Same thing that we did before. And here we're going to go through and add multiple cameras. The definition of the camera is mostly the same. We set the field of view, so the angle that we want to see. We set and then we half the aspect ratio, because we're only going to be drawing to half of the window. So we want the aspect ratio of all the stuff that we're drawing to be half. So we multiply the aspect ratio by 0.5, then we set the near and far boundaries like we did before. We move this camera back so that we can look at the cube, and then we give that camera a name. And then this is one of those helper functions I was using before. I'm still just moving across the z-axis, but instead of just depending on the fact that it's going to be pointing at the box, I'm going to say, hey, camera, look at this box object that I created and add to the scene, and let it do all the math to like turn the camera. Then we're going to create another camera. We do the same definition. We say here's the angle that we want to see. This one's going to be a little bit wider, and then we'll do half of the aspect ratio again. And then the near and far, we're just relying on the defaults. I think the defaults are near is 0.01 and far is 1,000. It's either 100 or 1,000, but either way, we're just going to let those be the defaults because we don't care about that. No, I just didn't feel like defining it. And so for this camera, I know I wanted this kind of like over the shoulder shot. So we told the camera to move back or move forward 50 and then move up 50. We gave it the name, and then we said, okay, camera, look at from here. Look at the scene origin. So we're saying move it back and then point yourself at the origin of the scene because we know that's where the cube's going to be. We could point it at the cube, but just point it at the middle of the scene. So from here, we create the orbit controls, and then we pass it to that class that I defined. We pass the orbit controls and the two cameras, and then that camera controls class is just going to manage all that interaction for us. And then here is where we start adding the helpers. Three.js has a bunch of helpers. I'm showing the axis grid and oh god, axis grid and axis. The axis grid and frustrum camera helpers here. But like there's a whole bunch of other helpers that you can use to kind of inspect the scene. So we'll go through and we'll create a camera helper and we'll tell which camera we want it to be attached to, give it a name, add it to the scene. We'll create a grid helper. We'll tell it the size of the grid, both like how wide we want it and how big we want the grid lines, the grid line spacing like in the grid to be. Give it a name, add it to the scene. We create an axis. Oh, yep.
So that is not a true surface or mesh. It's literally just draw lines being like
Yes,
being drawn.
I'm pretty sure. Yeah, I haven't looked at the underlying code behind the helper, but yeah, it's probably just vertices and edges, so lines being drawn. And then we define the axis helper. We say how long we want those axis lines to be. Give it a name, add it to the scene. That's it. So like adding helpers in is really quick, and you could tear these out later if you need pretty easily. After that, we do the same stuff that we were doing with the animation loop before, or the basic steps. But see, frame doesn't matter. This is what I was doing before, where we're showing the frames being spit out. The biggest difference here is that at the top of our animation loop, we say clear out everything that was drawn before, and then we're going to rotate the box, and then we're going to make sure that the helpers are not visible, because on that first tap, well, I guess we made sure that only one of the helpers, sorry, the helpers are visible by default. We're turning the camera helper off, and for some reason I decided to leave the other two helpers on. I mean, it does make sense whenever you're looking at it. But we're saying, okay, move the box, show these two helpers, don't show the third one, and then let's render. And whenever we render to the viewpoint, we're gonna say, so if we're looking at the browser window here, start at the far left corner and start at the very top, and then draw left to right the half of the screen width, but then the full screen height. So draw. We're not drawing this other half, and then or we're saying this is the viewport that you're going to draw across, and then we're telling the scene the renderer to take all the objects in the scene, take that first camera, and then draw the scene relative to that camera. So we draw one half of the scene, and then we say, okay, turn the other camera helpers on so that everything is showing. The object or the cube has still been moved, or the cube is still at the position it was whenever we moved it just a little bit earlier. And we say, okay, now this time the viewport that we're going to draw across is going to be half of the scene width, or start from the browser window, start halfway across the width of the browser window, and at the very top of the scene, and then draw half of the scene width and the entire scene height. So whenever you render, draw. The left half of the window has already been drawn. We're just drawing off the second half with some adjustments that we've made before. And then tell the renderer to draw that second half, and then we go on, and that's what we're seeing here. So like in each frame, we draw half of it, and then we adjust what we want, and then we draw half of it, we adjust what we want, we draw the other half of it, and like on the first half we use one camera, on the second half we use the other camera. and that's it. Like there's nothing more complex to even this slightly more complex example doesn't have anything more to it than a little bit different management of how we're drawing. Okay, so so from here we've like everything that we've been talking about so far is drawing onto a browser window, either for your desktop or for mobile. One of the things that you could do with 3JS is a VR experience. This is actually a shot from one of the projects that we worked on, where we were doing a guided tour of 360 images and video through a football stadium. This part was drawn with a different 3D management tool, but this half was 3JS, and actually you could see it like right here. This little line. We used the Oculus One, so there was a little handheld remote that you could use, and it was pointing out to different things so that you can interact with it. And that the line that comes out doesn't actually do anything, but it's a representation of a ray trace. So whenever you point the cursor, in code, is ray tracing along that line and seeing what it's intersecting with, and then allowing you to interact with it from there. So VR and WebVR, they're outside of what we already went over. There are two main differences and things that you need to do a VR or a WebVR experience. You need a stereoscopic view, so it is two renderings of the scene. They're positioned a little bit differently, so that each eye sees its own scene, and they're angled just a little bit so that you get a three-dimensional view, like in your eyeballs, and then different camera controls. So for WebVR or for VR, if you're doing just browser-based VR, the big difference is that you're not using orbit controls. You're not using your mouse to move around within the scene. You're actually using the device's accelerometer to say this is where the camera should be pointing. So there's a different library that does that. The difference between VR and WebVR is that as far as 3 is concerned, is VR is a JavaScript library, or like the device orientation controls is just a JavaScript library that you pull in, just like you pull in orbit controls. The WebVR is actually an API that is being developed that give you access to your device's sensors, like the accelerometer in your phone, or in the Oculus Go, the accelerometer in that headset.
Would that be equivalent to Cordova for the Oculus? Whereas Cordova is to native mobile.
I don't know, but mostly because I don't really know enough about Cordova. Like, the Cordova gives you access to, like so it would be like the same kind of interface, at the very least conceptually, if not the same kind of reach into there. So VR demo. So we've done at Paradowski, we've done 2 major VR experiences so far. We did that stadium tour. Actually, no, that's not fair. Recently, we've done 2 major VR experiences. We did that stadium tour, but we also did a cool tour through...
Hi there. Thanks.
I forgot about that audio. A cool tour through our office. So we're not gonna... Let's see. I'll simulate the VR experience in just a second, but just to show it in the browser really quick, it will be helpful. The upside about doing 3JS without WebVR is that the same code base this code base is being used for the browser, so it's using orbit controls to move around. If you put it into a mobile formation, it will use the device orientation instead and do the stereoscopic view. So you could use the same code base, same URL to do both a desktop and a mobile VR experience. In this particular case, let's see. there's a bunch of audio for it. In this case, where we like this in this 3JS experience, there's a giant sphere geometry. It's a sphere that is larger than our camera, and the normal face for it, the face that actually shows on that that geometry is inverted, so it's pointing inward. So right now we are sitting inside of a sphere and then looking at what's being plastered across the inside of it. So whenever we move the camera around, we're just looking at different parts of the sphere, and we're using a material to map a 3D video across that sphere. So it's an equal rectangular video. So it's one like when you do a panorama view, it's kind of that same effect where it looks really warped. But whenever you put that panorama view into a circle, you're able to look around and see that. The 360 video is similar to that. It's just like instead of a circle, it's a sphere. So we're looking around the sphere, we're moving our camera around, and then we're ray tracing to different objects within the experience, and either creating a plane to show a regular video across, or using a marker that is being positioned relative to the scene to navigate through or to switch to a different video and navigate through the office. So, and then from here, there are a bunch of different markers that you can look at to, oh God, it's really weird controlling this way. But there are a bunch of different markers that will take you to other videos, other 360 videos, and show what's going on in our office. So this is all 3JS with just device orientation to control the camera. If we simulate a phone, oh, why don't you give me my dev tools? Oh my God, why aren't you giving me my dev tools? There we go. No, you can. This is public, so you can go to vr.pc1.fun if you want to look through all of it. And I would suggest you do it because it's a pretty cool office tour. So if we simulate this and we flip it, how do we flip? Help me out. How do we flip it? Like whenever we were developing this, I didn't use this method of showing the 3D experience. Yeah, I thought it was just a.
Make your dev tools smaller on the left side or right side so you can see. Yeah, there you go.
Oh, okay. I was about to say I didn't think it was all that complicated. So if we refresh so that it thinks that it's a phone, come on. Ignore those errors. Default is an exception. Skip. So once it finishes loading, we get that stereoscopic view. So like and we're not doing this manually. There's a library called stereoscopic view that will do that. Will do the two rendering like we were seeing before automatically, but also adjust for it adjusts for the way that your eye is supposed to see it, because you're not looking just flat onto the same image. It's actually tilted just a little bit so that you get like a 3D view. But really, it's just this and the difference in controls so that you can see which way your phone is pointing that allows you to do VR. The hidden button? Oh yeah. Yeah, so yeah, that's interesting. I like the headset that we developed for. So this is a Google Cardboard. I'm glad you said something because I forgot I had sitting here. This is one of what Google developed to push VR. It's giving you the two lenses that you need to like focus to see the three-dimensional experience. And the button that Sebastian is talking about is this button up here. And the Google Cardboard, all it does is it has a pad here that simulates you touching the screen. To do a tap, which is important for WebVR because with the way that the browser is currently set up, you can't actually load videos. You can't load videos without a user interaction. So we had to like come up with a strategy of how to build the interaction that would get the user to pull up the website on their phone and then initiate, like physically initiate an interaction so that we can load all the videos and play them and stuff like that. So that's why whenever you see this go, and whenever you hit that go, that is the user interaction that is triggering in the background us going, okay, start pulling all these 3D videos and pull them as fast as you can because they're big. And then like go through and play all of them and immediately pause them so that it forces the videos to load. Because after that, everything from here on out is just like us like either doing a ray trace to say I touch this particular object, or well yeah, is just ray tracing. So it's all programmatic. So all the videos have to be loaded because we can't load another one once you're in this experience because the headsets that we didn't have, or that we use, didn't have a button. If they had a button like this, we could just say, okay, load just the assets that you need, just the videos we need up front, and then as you either get close to something or like do something in the experience that tells the user, click this button, that gives us another physical interaction that we could say, okay, really quickly load all these other assets and kind of like space it out that way so that there isn't a major load up front. So there's like, so it's interesting. Whenever you do talks like this, it's good to give an intro, but there's so much strategy outside of just the basics that an actual project will show. There's other stuff that we went into, but we could spend an entire night talking about that demo, and I don't want to revisit some of the stuff.
You guys buy the 3D camera?
Yeah, we had a 3D camera before. We have a Ricochet Theta something. Okay, so starting to wrap stuff up. Snags and consideration. So these are some of the things that will make kind of like be the guiding posts of like, do we do this in the browser? Do we do this native? Performance on phones is an issue. With that Office tour, the issue was less about the 3D experience, like the 3JS stuff, because even at its most, it's just drawing stuff. The issue that we had was videos, like pulling down 360 videos, which are massive even at just standard definition. Pulling those down, loading them up, and being dependent on a Wi-Fi internet connection because you're going to a phone, not to like wired like a wired computer or something like that. So there were issues like whenever you have a web experience and you're pulling stuff down from the server, that load time becomes an issue where if you had a native experience, maybe it wouldn't be because you already have everything. The dynamic fonts, we did like whenever you look at that 3D tour, get rid of that.
Hi there. Thanks for checking out Paradise.
So whenever we look at the text in this particular tour, these are images of text. These are like we took images of text, we wrote it out, took the images, inserted the image, so that we got a flat image of the text. Because if you do three-dimensional text, all those polygons that you're drawing, you have to draw for the entire shape. Even if the text is super flat, you have to draw everything for that text. So that even like a mild amount of text starts to add up a lot on performance. So for this one, we use images. For the stadium tour, we basically created. There was a guide that Google gave on how you can render out fonts dynamically, like just draw them into the three-dimensional experience and draw them flat. and we ended up going with that route, and that had some pluses and minuses. But doing dynamic fonts in 3 can be a little bit of a headache. There are other methods that you could do where you could define an HTML element and then pull that via JavaScript and then load the text in that, which is fine. But it's always a forward-facing flat text. Like you can't look at it like that. It's always going to be facing you, and it's always going to be layered on top of the experience. So if it passes behind something, it's really passing in front of it because it's layered on top of it. Battery consumption on phones. If you're going to be spitting out 360 video, it's going to have an impact on your phone's battery, and it's not horrible. Like it wasn't killing my phone during the day whenever we were working on it, but it's considerable whenever you're talking about web experience. Older browser fallbacks, and actually it shouldn't be even just be older browser fallbacks. It should just be browser differences. The same things that you run into whenever you're building a web experience, where you need to account for differences between browsers and really what's not supported by some other browsers. You have to think about that when it comes to building out this experience, whether it will run efficiently or whether it will run at all.
So is that just the browser, or do you also have to worry about the graphics card or capabilities?
On your phone.
It's a question I have for from laptops.
On your laptop, I don't think I don't think the graphics card. I guess I should say I'm not totally sure. I don't think so. I don't think it's a big issue. I didn't see anything that in the readings that we did when we were looking at researching performance and stuff, that was talking about the graphics card specifically. But I guess I don't know for a fact.
It probably falls back to CPU processing if it can't do it on the card.
Yeah, probably.
So that probably depends on the speed of your machine, on
Yeah.
how slow it should be.
Yep. So, that will go through. So I listed out a couple of examples to check out. This is the dancing example, and it's totally worth exploring. Partially because it's hilarious, but also because when you think about what it takes to, why don't you let me click? Oh, because I'm clicking the recording. When you think about what it takes to draw this on the screen, to organize this data, to like live load and render all these objects, to go in and be able to change different aspects about the objects as you're rendering them out. Like this example is deceptively complex. It's very, very cool to play around with. Let's see and then and really most of these are from the 3JS website. When you go to 3js.org, this is all demos. So you can come through here and hop through to a particular demo, check it out, and then come back and look at a different demo. Totally worth exploring, both to see get an idea of what you can do, but then to also see. It's gonna take forever to load. To also see where 3JS has been used, like the Cassini Grand Tour demo is a 3D experience that NASA had built to show Cassini as it was getting close to all the paths that Cassini was going to take around Saturn and its moons. There's some cool examples from Google. There are examples of games like Cube Slam. This may load fast enough. So you could do an interactive experience, and you can as soon as you could do an interactive experience, you could do a game around it. So Cube Slam is a really cool 3JS game where you're playing Pong, either with someone else or against a robot player. Yes, disable shields. Yes, that's fine. So, and it gets into things like the physics and the different angles and stuff like that, and you can see examples of how to render out experience, render out stuff in the background, etc. So I would say go through and explore these examples. And then also, before I get to that part, another important part about Three.js that you should definitely do is whenever you go to the website, look through the documentation. It's not the best, but or like, I don't know. The documentation's fine. I'm just spoiled. But the definitely check out the examples. So for all of the main tools that Three.js has, there are examples of how to use that tool. So you can come through here. You can look at a particular tool that's being used, and then down in the lower right-hand corner, you can pop out and look at the source code that's been used to generate that tool. And when it comes to this code base that has pretty complex tooling and stuff like that, seeing how things are knitted together and being able to see how you can accomplish some of these really complex examples is highly beneficial. It's almost required as you kind of start wrapping your brains around this library. But yeah, and like all the examples are interactive. If we look at the device orientation tooling, oh wait a minute, nope, that's not the one I'm thinking of. When you look at the orbit controls example, man, which one am I thinking of? There's one that allows you to look through a three-dimensional, like a VR experience, and then there's a cube that's being rendered in the middle, and there's an image that's being mapped, image material that's being mapped to all the sides of the cube. That I was going to show that was basically using an image to do the material, and all it is like a PNG of a box. And it's the side of a box, and you put it onto a cube, and if you put it on all 6 parts of the cube, it just looks like a crate. So definitely go through and explore those examples as well. So as we talk about Three.js is just one tool that allows you to do this. There are alternatives like Babylon.js, which is developed by Microsoft, and or Play Canvas, which is similar to Three.js, but it has a game focus, so it does things like physics and like some of the trappings that you need to actually develop a three-dimensional game. There's A-Frame, which is a framework built on top of Three.js, and then there are a bunch of different two-dimensional tools for this, like Paper.js, which does essentially the same thing, just on like the X and Y plane and not the Z. But it draws to a canvas element using WebGL.
Sounds a lot like SVG.
Yes. Yes, it does. Yes, it does. It makes me want to go to a talk on Paper.js. It makes me want to go to a talk on SVG to hear an explanation about that. Yeah, I wonder when that's going to happen, huh? So from here, I say further exploration. Definitely go to Three.js's website. Definitely go to their examples. And then there's also this great blog post that I happened to find after we had done a bunch of Three.js work, and then part of the way through putting together information for this. That is a really good introduction to Three.js. Probably, I mean, I'm sure it's better than what I did here, but it goes into a lot of detail about the bits and pieces. It's totally worth a read. And that's it. So if you have any questions, you can find me on all these places. You can see stuff that I do outside of this. The Three.js world is very new to me. I do a whole bunch of other stuff, both in the programming and makerspace. So you can look over there, and you can like when I was putting together the slide, totally aside, I realized how many places I was able to get my name without any numbers or additions. I was like, oh yeah, early adopter to a bunch of stuff. So, but that's it. It's the last slide.
I have a question.
Yes.
Have you ever tried integrating this with other libraries like React or Vue or?
That is a good question. I have not tried integrating it with Vue, but it's only because we built our own framework for these experiences. We wanted to try and do it with do like the tour and the stadium without like any kind of a framework on top of it, just because we wanted to, and we wanted to keep it like as lightweight as we possibly could, especially with all that 360 video. So those experiences, we didn't write like the example code that I have up there. The example code, all this example code is very procedural. It's very like top down, single file, define, and then render it out. But when you're building an actual experience that gets a little bit more complex, that's not an ideal way. I would not write it at all. So we ended up writing either wrapper classes around some of the 3JS tooling to do things like to create a marker. A marker is we use a like just a regular 3DS or 3JS cube shape for a while, and then replace it later. But it was just like, all right, whenever you instantiate this class, you can give us some constructor stuff, and then we'll do all of that define, like creating the material, creating the geometry, creating the mesh, and then passing back the mesh. So we did that, and then we created a container to wrap the scene and the renderer so that we could like better organize the events that are happening and move around through the experience and stuff like that. So you'll probably not like for small stuff like single page simple stuff. You could totally get away with writing it like that. As soon as it gets a little bit more complex, it's worth it to kind of break it out into like an object-oriented or module style. As far as integrating it with things like Vue, I've considered doing it. I haven't just because I haven't. And then also because like Vue and React and stuff like that are very centered around managing the markup and the state of the markup and stuff like that. And whenever it comes to this 3D experience, like there's barely any markup at all. There's still an advantage with the state management for sure. Like you could probably even just do like Vuex or Redux or something like that on its own just to handle the state management and interactions. But yeah, we just haven't tried to put it into a framework. But that's a good question. Any other questions? All right, well, thanks for coming out. If you didn't sign in, please sign in, and see you at the Full Stack meetup.